Mechanics could be easily divided into two branches, namely kinematics and dynamics. Kinetics deals with the motion of the body and dynamics deals with the cause of this motion. So the physical quantities like force, impulse, momentum, work, etc., they are under dynamics. So now we'll try to define force. A push or pull which stands to change the state of rest or uniform motion is called force. So by pushing or pulling a body at rest, we can change the state of rest to motion. Or even applying push or pull to a body at motion, we can put it in rest. Hence, force can be defined as an external effort which changes or tends to change state of rest or speed or direction of motion of a moving body. The SI unit of force is Newton and is denoted by capital N. Whenever a body is in motion, there used to be some kind of obstruction that prevents it to move easily. That one is called as friction, and friction is also a force. You might even wonder, is friction necessary? Yes, the answer is yes, because without friction we will not be able to walk, sit on a chair, or we might not be able to stop the vehicles from colliding with other objects. Now let's talk about balance and unbalanced force. You might have seen a game of tug of war in which two sides are pulling each other trying to win, and suppose the two sides are having equal strength. That means they might not be able to pull each other. So in that case, we can say that the force they applied are equal and it is balanced force. But if one side is stronger than the other, they will pull all the other teams to their side. That means the force they applied, the pull of both sides are not equal. Therefore, we used to say this as unbalanced force. When two or more than two forces act on the same body, then they would give rise to what we call as resultant force. Let's try to explain it more clear using an example. From this image you can see that the two small boards are pulling the bigger board. The force given by the two boards are T1 and T2. The resultant force given by them will be along F. As you can see, the big boards will be moving along F. For the second experiment, we have a trolley which is stationary. But when two forces which are 60 Newton and 30 Newtons are applied in the same direction, then the resultant will be 90 Newton towards the right. That means we are adding up the two forces since they are in the same direction. But in the lower one, the trolley is now acted upon by two forces which are in opposite direction. We have 10 Newton acting towards the left and 30 Newton towards the right. Since their directions are different, we have to subtract 10 from 30 Newton. The resultant will be 20 Newton and it will be towards right.